Ladies and gentlemen, please welcome the SIGGRAPH 2023 Real-Time Live Chair, Dr. Jem Yüksel.
Hello and welcome to Real-Time Live. Well, I would say this is the most exciting event at SIGGRAPH. Well, okay, there are lots of exciting events at SIGGRAPH, but so it's debatable, maybe, but this is definitely the only one with an exclamation mark in its title, isn't it? So what makes Real-Time Live so exciting is that everything you see here in just a little bit will be generated real-time, live on this stage with using these various computing devices that you see up here with me. That's going to be the excitement, right? Now, you're about to witness the latest and greatest technologies and applications for real-time graphics and video games. And talking about video games, we have something new this year. We are live on Twitch, yes! Hello, Twitch! All right, we're sharing the love and excitement of real-time computer graphics with the whole world, and we are doing it live. So, please do me a favor and pull up your phones and take pictures and videos whenever you feel like it. It's not only permitted, it's encouraged in Real-Time Live. Feel free to share them with the world, and while you're doing that, you might want to use one of these hashtags like SIGGRAPH 2023 or Real-Time Live. So what you're about to see is one of the biggest Real-Time Live shows ever. We have 13 demos this year. All of them are selected by, well, not me, they're selected by a jury. The Real-Time Live jury. And the jury will also select the winner of the Best in Show award. Now, we don't know which one yet, well, because the show hasn't happened yet, right? And you, I mean everyone sitting here in this room in Los Angeles Convention Center, and everyone watching this online on Twitch, you will vote for the Audience Choice Award. And that's going to be fairly easy. That's very easy. Just go to this URL, all right? And you can see that. You can actually type it, or you can use the QR code if you want to. That's totally fine. You can do that now, or you can do that later. Don't worry. But you can wait till the end of the show, and I will show this again. And you can scan it then and get it, or you can have it ready now. That's perfectly fine. It's totally up to you, however you feel like it, all right? But then, right at the end of the show, we will have very little time. This is Real-Time now. We're not going to wait. This is Real-Time Live. We are not going to waste any minutes. So we're going to find the winners right away. You'll have only a few minutes to put your votes in after the show ends, okay? So be prepared. And after that, we're going to get the votes, we're going to tally the votes, and we're going to give the two awards right here and then. And we're going to know who won, right? All right, let's get this started. We're starting Real-Time Live today with Feature Film Quality Characters Anywhere by Ozone Storytech. And our presenter is going to be Rich Hurry. Rich is a 25-year veteran of the computer graphics industry and the president and head of product at Ozone Storytech. Rich?
Hi, my name is Rich Hurry, president and the head of product at Ozone Storytech. Ozone is being developed, when I put my glasses on I can read my script. Ozone is being developed to empower rigging artists to create characters faster, smarter, and at the highest possible quality. And audience, tell Rich to hit play on the thing. Our characters are truly portable, allowing them to be rigged once and animated anywhere. Zoe here was animated in Maya, but is playing back live directly in Unreal using the Ozone deformation system. Traditional rigging systems are built on the back of normalized weights, joints, and blend shapes. Ozone looks at deformations differently. For instance, Zoe's face here doesn't use any joints or blend shapes. Now let me load up another scene. All right, and we'll go to the wide view. Ozone is based on a layered order of operations-based approach. Along with independent animated weights, this provides a far more precise way of moving points in space. In this example, we created a magic carpet that again is not using any joints or blend shapes, but takes full advantage of independent dynamic weighting to achieve great results. And for any of my rigging people out there, imagine trying to rig this with a standard joint setup and how hard that would be, right? So this illustrates how with ozone, you can do far more with far less to achieve similar and often more complex deformation results that can be easier to create, manage, and deploy in production. Now let's look at something that's maybe a bit more practical than a wacky magic carpet. All right. So this character was designed by Rowena Fresnel, who's an amazing sculptor and character designer. And if you haven't, please check out her work. Looking at this practically with the puppy, the body is driven by our joint solver, but is connected to standard joints. We are using a parametric bend to drive the tail, and with ozone, you can use the best deformer for the job. You're no longer limited to the two-hammer toolbox, joints and blend shapes. All right? So let's talk about quality, which is a big deal for us here creating ozone. So ozone characters achieve the kind of quality you would expect from a feature film. And if I double click on it, it will load. Let's hit play. All right. The kind of quality you'd expect from a feature film, TV, or AAA game production. With the ability to rig your character once and animate it anywhere, this high bar can be maintained no matter where your character is deployed. Here is Dee. She's our main character for a short film that we call Like. It's directed by Mark Walsh and being created with the support of both Epic Games through their Mega Grant program and AMD with direct engineering support and providing amazing hardware. I can tell you, Threadripper Plus Radeon Pro is a pretty amazing machine to work on. Anyway, you can see these kinds of shapes we're able to achieve here, just like something you would see in a feature film animation production, but right in Engine, okay? We also have subdivision surfaces. So let me show that here. Right, so what this means, select her, and let's bring up the sub-D control. We can dynamically change the resolution of the model on the fly, right, which is a very big deal in TV and film production. It means that we can rig the sparse cage, which means rigging less points, means faster rigging, and still getting perfectly smooth results in the final output, all right? All right, let's take a look at another scene here with Dee. We'll bring it in there. Load her up. All right. And let's make sure I'm hitting the right camera. There we go. Ozone characters are fast. Animators can count on their characters running in full frame rates without compromise in any environment they're working in. In Maya, this means multiple characters all running at full speed with no caching required. In Unreal, characters running up to 100 frames a second or more. Gone are the days of low-res proxies or layout-only versions of characters. Now, everyone in your pipeline can work with final characters at speed and in context. Now let's load up something from a live production. There we go, load these up. Nothing like a slow load in front of thousands of people. All right, so take a look here. So these characters were created in Ozone by Real Effects for the show Supergiant Robot Brothers. It's directed by Mark Andrews, produced by Netflix. And for the record, I want to thank them all very much for taking a chance and using Ozone on their production. Now, as we launched Ozone, we focused on virtual production pipelines. That means animating in Maya, rendering in Unreal. We started by making it really easy to bring Ozone assets into Maya pipelines, allowing for most of the studio's existing character tools to be adapted to Ozone easily. Now, let's load up another one of the characters on our show. This is the main character here. All right. Doo-doo-doo.
That's a Roger.
Right.
Twister.
So these animations here were exported out of Maya and imported into Unreal using our clip format, which is 95% smaller than the equivalent Olympic file. This means a much smaller memory footprint, network data requirements that are much, much smaller, and Unreal scenes that load much, much faster. Ultimately, this allowed for layout TDs, animators, lighting, and rendering artists to produce more work in less time. To close, Ozone is being designed to be the best rigging tool that has ever been created. Designed by rigging TDs, for rigging TDs, providing a complete character solution that enables artists to create the highest possible characters, deploying them anywhere, all without compromise. And I'm gonna sneak one last little thing in here before they bring the hook in to pull me off stage. This is a shot from our short Like. I want to thank everybody for watching, and if you want to see any more Ozone or have any more questions, we'll be at the AMD booth during the show. or you can head to ozone3d.com for more info. Thank you very much.
Thank you, Rich. This was fantastic. Like, all these characters are coming alive, aren't they? All right, next up, we have real-time collision using AI by Apagom AG. And our presenter is going to be Lubor Laditsky. Lubor earned his PhD in computer vision at Oxford Brookes University. After working as a researcher at University of Oxford and ETH Zurich, he started Apagom AG, focusing on real-time simulations with AI. Lubor?
Thank you very much. So collision detection. Collision detection has been solved roughly, 50 years ago. So for the 50th anniversary of SIGGRAPH, we decided to dig the corpse out and put it to the test. If you do this test yourself, you quickly realize that collision detection works really well for a large set of or for a small set of primitives. It works kinda acceptable for, convex hulls, but if you want to apply it to a general shape like these ones, the performance is quite abysmal. You need lots of parts with convex decomposition and so on, and simply it's not very practical. And all these problems become even worse if you want to apply it to deformable objects like these ones, so elastic or plastic deformations, because in that case you need to update the representation every frame, and even a calculation of a single convex hull is rather slow. And as you can see, we are able to simulate these kind of simulations, 64 FPS, and it runs on a single laptop. We are also able to simulate destructible bodies. So this simulation should eventually end up with over 6,000 parts. As you can see, it works kinda well. And all these things have been designed to run on GTX 1080, which I was originally supposed to use for this presentation. And it runs just fine. So the question is, what exactly are we doing? Oh, wait, that's the wrong window. So first thing is that we designed a new data representation, which represent each object as a collection of parts, where each part is an intersection of a set of quadrics, that means second-order equations. And with this representation, any primitive, I can change the animation. Any primitive can be represented exactly, so we have no special handling of primitives. We just treat them the same as any other object. And if we also design an algorithm which can simply decompose arbitrary shape into this kind of data representation. And then we are able to select, let's say, number of parts or a number of equations interactively, or based on the approximation error, or it can be done also at runtime if we really want. And then once we generate such model, we can just place it in a simulation. So we have a large set of ragdolls. You can zoom it, they are all hitting everything. And to calculate collision, what we have to do is we first find the deepest point with a correction to continuous collision for each pairs of parts. And to do so, it ends up being a so-called semi-definite programming problem, and the solvers for such problem are actually really slow and really slow. So what we do is we use the latest magic, a variant of recurrent neural network, which simply predict this deepest point for us. And except the deepest point, we also calculate that intersection polygon for each pairs of objects, which makes simulation very stable, as you can see. It gets rather boring. This is used as a multiple contact points to get a very stable simulation. And the optimization problem which we get is very similar to the problem which we get for deepest point, so it's kind of done in a similar manner. As any convex technology is distinguishable from magic, we have to support also something non-convex. So our solver works also for non-convex quadrics. So let's say this inverted torus can be represented approximately with just a few equations. As you can see, it works just fine. And if you want to do it with standard convex decomposition, this would be really terrible. I mean, really terrible. For your homework, you can try to do it yourself, and you'll see how terrible it is. Our data representation was originally designed as a collider for particle simulation. So this is our particle simulation, which are our fleet simulation with roughly 6 million particles, which I presented at Real-Time Live a few years ago. And the reason why this is suitable for particle simulation is that to calculate collision, we just need to be able to calculate collision with a single quadric, which is rather trivial. Also, the whole pipeline is differentiable, so we can place it in any reinforcement learning framework, for example, for training these virtual characters like this one. So basically, we get an AI character simulated with AI physics, with AI fluid, with AI surface generation, so lots of AI everywhere. So you might ask, what's next? I think next, this character will realize that he's living in a simulation. Then he will get really angry at me for throwing that stupid duck at him in. Then he'll escape simulation, and then he will kill us all. But you can relax. You can relax because your safety is our priority, and this is only part of the future work. So thank you very much.
Oh, that was absolutely fantastic. So many things colliding, isn't it? That was great. All right, next up, we have Roblox generative AI in action. And our presenter is going to be Brent Vincent. Brent is a serial entrepreneur who runs the scripting team inside Roblox Studio with a focus on accelerating creation on the Roblox platform with generative AI. Brent?
Thank you. Hi, I'm Brent Vincent, and I'm here with my assistant/boss, Steph Carazza. We lead scripting and all of Roblox Studio, respectively, and are happy to share some of our team's work on generative AI in action. Let's take a look at AI coding and see if we can make an orb turn red and disappear shortly after the player touches it. At Roblox, we envision a future where anyone can create anything, anywhere. With over 30 million experiences already on the platform, the creator team at Roblox is well on its way to bringing this future to life. So first, we write the code to make the orb turn red and disappear. The code is generated by AI. Let's make it a 3x3 grid of orbs. Again, we say what we want, and the model generates the code. Next, let's add some sound, some buzzing noises that line up with the orbs disappearing. Once again, we will describe what we want, and the model will fill in the rest. Roblox is a vertically integrated platform, inherently scalable, safe, and social. As you can see, the code is there. It's the easiest platform to create multiplayer games, providing distribution, scaling, networking, payments, and analytics, all out of the box. And as you can see, the code works. Next, let's go live and see if Steph can show off AI material generation to change the materials for a door and a Lamborghini. Some essential metrics while Steph is getting things started. Roblox has over 300 million monthly active users, with over half of those users over 13 years old, and the fastest growing age group, 17 to 24. We have over 4 million creators earning money on the platform, with 90,000 new experiences published every single day. I'm liking these door materials. A platform like Roblox is a great match for AI. As you can see, lives don't depend on it versus flying planes or driving cars, and creators can just take what they want from AI. Some key lessons here, 3 of them. Number 1, The latest generation of coding models is already pretty good, even at baseline. Number two, fine-tuning the AI model significantly increases the quality of the output. And number three, having a testing automation harness is super useful for fast iteration. To make generative AI effective, context is crucial. The effectiveness of AI grows exponentially with context. This means, in the case of coding, more code in the current script, but also more metadata and code in the project and beyond that the models can leverage. With sufficient context, we've seen the acceptance rate for AI-generated suggestions, whether for materials or code, increase by more than 50%. Let's see if we can take the Lamborghini down a visual level, depending on what you like. While we've primarily covered coding here, code generation models also show promise for at least 4 other important use cases: documentation, rapidly identifying the right function for the job; code understanding; debugging; and education. Now, once Steph is finished playing with the car, let's make the code do something more interesting. I'd like to see if Steph can begin to channel his inner Michael Bay. Our aim is to democratize creation, making it easier than ever for anyone to bring their creative ideas to life on the Roblox platform. Right now, we already have experiences that allow inexperienced creation, but the content is locked. We're building APIs so users in an experience will be able to publish to the platform, and those creations will have a life of their own, providing an easy on-ramp for people to build something cool, fast, in the context of an experience they already know and love. Let's let Steph finish this code so we can see it going. We expect to continue to see the rapid evolution of development and creation tools, constrained only by available compute and our collective ability to effectively capture intent. We hope you're as excited about this space as we are, and we look forward to seeing what you create. Both Steph and I will be available after the show to continue the conversation. Let's see this run. First that, and let's see Steph's driving skills. All right, another important lesson: drive carefully. Thanks for watching.
Wow, that was, I have to say, in the beginning, that was some impressive speed typing and even faster speed coding. I could get used to that. That was great. Next up, we have Suit Up AI mocap, and it's going to be by Movers. Our presenters are Agiris Kashitofish. Agiris is a co-founder of Movers, and he's received his PhD from the National Technical University of Athens in 2022. His R&D work focuses on computer vision and machine learning in the academia and industry, working on motion capture with volumetric video. Spiros Thermos is our other presenter. Spiros is a research scientist working on human body motion digitization and creation. Previously, he was a postdoctoral researcher on generative AI at the University of Edinburgh with a special focus on disentanglement and image synthesis. He is also a co-founder of Movers. Take it away.
All right, thank you, Cem. So, hello, SIGGRAPH. At Movers, we are committed to making optical motion capture less rigid and more affordable for the broad content creation community. Today, we would like to present Suit Up, our AI-based motion capture for real-time character animation. So, the current stage of marker-based mockup includes systems that use specialized cameras for ensuring marker tracking precision, which guarantees high-quality mockup. We explore a new pathway, a different pathway. Our system is able to operate robustly even with noisy marker input, captured with a very sparse set of low-cost and off-the-shelf cameras. For example, our demo setup today works with only 4 calibrated Kinect cameras, which you can see as colorized 3D assets in our studio. Our actor wears a suit with 53 passive markers covering his full body. However, note that the number of markers and their placement are just two parameters of our AI system that can be tuned. But enough with the background and the details. Let's dive into the setup and meet my colleague Argyris. Argyri, the floor is yours.
Hello, SIGGRAPH. This is an AI mockup that requires no initialization pose, like a T pose or an A pose, to perceive the human body structure. It automatically calibrates the human kinematic tree using raw unstructured marker inputs. Each sensor provides a set of noisy marker measurements color-coded to show the originating sensor. For example, you can see the yellow sensor on my left or the red sensor on my back. The low-cost sensors produce a noisy marker input that our system successfully denoises to produce stable motion capture outcome. Our AI system is able to robustly operate with very sparse viewpoints. We can block one camera and see that the outcome remains intact. We can block a second camera, leaving no frontal viewpoint, and the system still performs. Thank you, guys. Our AI system, now, basically, we are going to demonstrate how our AI can compensate for the existence of extra markers, enabling the use of props. You can see the markers, but the motion is still correct. Thank you. Our system is able to operate robustly and overcome common marker tracking issues and occlusions. I can remove one marker and throw it on the floor. I can put it back in a different, not the proper position. We do not use marker tracking. We can swap markers without changing the outcome. Moving on to more challenging stuff, our system is adaptive to heavy occlusions. Let's remove 3 markers. As you can see, the result is still good. Let's remove some more. Even without 6 out of 53 markers, we get stable motion capture. Let's put them back. In a more realistic scenario, the occlusions might come from seen objects, like a chair. Don't forget that we use only 4 low-cost sensors and many markers are occluded. Now, let's demonstrate some suit-up performances. Let's do some physical exercises, typical ones. Let's start with some side steps. Or, for instance, some steps. Thank you. Some squats. And finally, let's do some push-ups.
All right. Thank you very much, Argiri. So that was Shut Up, guys. We're movers. If you're excited about our tech, either visit our site or we'll be around. You can meet us after the event. Thank you very much.
Now that's what I call a robust capturing system. That was amazing. Thank you, guys. Next up, we have Tell Me Inga, an interactive interview with a Holocaust survivor by Storyfile. So this demo actually has quite a few contributors, but 3 of them will be on stage with us. Val Jones is the CTO at Storyfile, enabling interactive video AI conversations to change how we communicate with each other and the past. Previously, Val worked on ITC Lightscape for human performance capture and glasses-free 3D displays. We also have Weston Gaylord. Weston is a writer and mixed reality creative technologist at Storyfile in Los Angeles. His original work often combines live performance, music, stereoscopic 360 video, real-time rendering, and room-scale photogrammetry for VR and AR. We also have Andrea Chabai, and Andrea Chabai is an interactive producer focused on marrying culture and technology. Her extensive portfolio includes projects spanning conversational AI, VR 360, volumetric multimedia, documentary, and digital camera productions. Take it away.
Thank you. Hi, everybody. Today, we're demoing Tell Me Inga, an interactive conversation with Inga Auerbacher, who was a child survivor of the Theresienstadt ghetto and transit camp during the Holocaust. Let's hear from Inga in her own words. Inga, can you tell me about a memory from your childhood? Let me just switch over to...
I think it's just me on mute.
Oh, it's on mute here.
Let's go back.
Okay. Let me... Excuse me just one second here. Val, why don't you share from yours?
Okay. So the first question you want to ask the question?
Yeah, so we're going to ask Inga. Inga, can you please tell us about a memory from your childhood?
My father loved taking pictures, and he took a lot of me. And here is a picture that is very sweet. It's taken in Kippenheim, where my mother and I look out of the living room when I was a baby.
We've done a lot of interactive conversations with Holocaust survivors, but this is the first one in VR allowing you to talk to a survivor. What was the night that changed everything?
In 1938, November 9th and 10th, there was a massive riot against the Jewish people. And Grandpa went to the synagogue in the morning to say his morning prayers, and he was arrested. The police came to our house for my father to pick up my father. And he was also sent to the city hall where all the men from age 16 were standing and waited to be deported. They didn't know where they were going. We were alone in the house. When the massive riot started, all the windows in all the Jewish houses and stores in Germany and Austria were broken. And that's why it's called crystallite, because of the broken glass. And I remember standing with my mother and grandmother in the living room, glass all over the place. And one of the hoodlums outside the house said, "Oh, the chandelier is still hanging." And we looked at the chandelier, and before you know it, there were rocks thrown through the window, and the chandelier was broken right above our heads.
Now Val's going to talk about the AI engine which powers this project.
Thanks, Weston. So our biggest challenge was trying to create an experience that didn't only work in VR, but also on desktop and mobile devices, like this. So for this reason, we decided to use Play Canvas, a WebXR native game engine, and we combined that with Conversa, our own conversational AI video platform. Now, Conversa allows you to take any expert and quickly turn them into a conversational video. So for example, I could switch over to another story file. And ask some questions. Hi, Andrea.
Hi, Val.
Can you talk about how we were able to create all these streaming animations?
The Quill 3D animations were converted into GLB object sequences with Draco compressions that could be then streamed via AWS Cloud from CDN.
So that's great, but what if you want to add like another video to this conversation? Well, luckily we have Andrea right up here on stage, so I can switch over to our Conversa platform and just hook up a web camera and I can hit record. 3, 2, 1.
Question.
Okay, helps I ask the question.
Oh.
Do it again.
Sorry.
How much video is recorded for this experience? 3, 2, 1.
There's 3.5 hours of video content in English and in German and 25 minutes of animation, as well as some historical footage.
Okay, I'll save that. And while that uploads, I can tell you a little bit about the rest of the platform. So Conversa is designed to quickly add questions. When you ask a user question, we use multiple sentence encoders to compare against existing questions in the database, as well as transcripts of other video responses. Our basic principle is that we do use generative AI, but to create other question prompts during the interview and to help train the story file. But ultimately, you have the authenticity of talking to an actual person with real video. So let's just switch back and see if that video is there. So go back to the Chrome. How many videos are in this experience?
There's 3.5 hours of video content in English and in German and 25 minutes of animation, as well as some historical footage.
Okay, so thanks everyone for listening. If you want to go talk to Inga yourself, you can go to inga.storyfile.com, that's I-N-G-E, or go to storyfile.com to try out Conversa. Thanks.
Thank you. This was really powerful, wasn't it? And you can see the excitement of a live demo. That was great. All right, next up, we have Chat Avatar, creating hyper-realistic, physically based 3D facial assets through AI-driven conversations. And with me on stage is going to be Qixuan Zhang. Qixuan Zhang is a graduate student at the Intelligent Vision and Data Center at Shanghai Tech University. As a Gen Z entrepreneur, he founded the digital human technology company, Demos Tech, and serves as its CTO. Qixuan?
Okay. Hi, I'm Qixuan, a first-year graduate student from Shanghai Tech University, and also my first time attending SIGGRAPH. And that is my assistant, Logan, third-year undergraduate students, also from Shanghai Tech and Demos Tech. Today, I will show you Chat Avatar, a new text-to-3D model engine. Each character you see on the screen was created through simple prompts by our users. Chat Avatar simplifies the creation of facial assets and provides the artist a useful new tool. Now let's give it a try. Just type in the chat window on the right, describing the features of character you want to create. For example, let's create Albert Einstein. Yeah. Our brainstorm agent, powered by GPT 3.5, will understand your description and provide a feedback. You can either keep typing your requests or select one of the suggestions given by the brainstorm agent. The secretary agent on the left turns your chat into a short prompt. Yeah. Then click Generate. Chat Avatar will first provide some candidates models that roughly match the prompts. Once you select a baseline model, Chat Avatar will improve the model's detail and then generate textures. While the model is being generated, let me explain how it works. The core modules, the first one, there are two core modules. The first one is a parametric face model called HACK that takes expressions, geometries, textures all into consideration. We presented this work at technical paper yesterday. The second is DreamFace, a 3D generation framework build latent diffusion model with mix of expert architecture based on 2D image features. We will present the detailed algorithms in our DreamFace paper on Thursday. Here you go. The final generated model with PBR textures. It only takes 30 seconds, so either Logan just makes this model in 30 seconds, or it is a real AI project. Since it is a web page live demo, we did not include eyes and hair, but our offline version includes these features. We can package the asset at different mesh, topologies, resolutions, and we can even generate riggings and full body complete with teeth and eyeballs. Let's try something else. How about let's generate an Oppenheimer. Just follow the same procedure. It is important to note that either Albert Einstein and Oppenheimer were in our 3D data space. As mentioned before, we use a parametric HACK model to first generate 200,000 face models with randomly sampled parameters. Given the text description, we add the clip features onto the pre-trained diffusion model to refine the final generated geometries. Okay. Yeah. So here is our Oppenheimer. It does look like the one in Nolan's movie. Here are some other models our users pre-generated. Recently, let's see what do we have. Yeah, this may be Miss Zuckerberg. Yeah, and that one may be the Miss Zuckerberg after the cage fight. Okay. Now let's try Jason Huang, because I just take a picture with him this morning. You probably find it may not look as similar to the real person. Our experiments discovered that it is largely due to the clip feature, possibly because not too many Jason's image data before 2021. All right. The Einstein model we just packaged is good to go. Yeah. With Chat Avatar plugins, we can import the 3D character asset into CG engines, such as the Unity, Unreal, Maya, Blender, and NVIDIA Omniverse. The asset package from Chat Avatar includes standard OBJ and FBX files, along with detailed PBR textures. Even the lip textures are clear. Yeah. Say the normal, say the specular. Finally, we can use the iPhone ARKit to control. Oh, it's not ready. Okay, here we go. Finally, we can use the iPhone ARKit to control the generated avatars. As I changed my facial expressions, the avatar moves accordingly. When I raise my eyeballs, Einstein does the same time. Yeah. You probably see our demos are very easy to try as our belief in simplicity. So please feel free to give it a try at Demos. That's all for our demo. Again, we are Demos Tech, a young startup from a young university, Shanghai Tech. Beyond the face, we are also working on generative animals, flowers, cars, shoes. Follow us on Twitter and feel free to message or email us. Thanks for listening.
That was wonderful. Well, I've seen Albert Einstein in various forms, but running around in the office was not one of them. That was great. All right, next up, we have intermediated reality with an AI 3D printed character. We're going to have two presenters here. Yogari Casas-Cambra is going to be one of them. He's the co-founder of 3Finery. Dr. Casas holds a PhD in augmented reality from Napier University. He was recently awarded a Young Computer Researcher Award from the Spanish Scientific Society of Informatics. We also have Kenny Mitchell. Kenny co-founded 3Finery and is professor of game technology at Napier University. He leads rendering visuals at Roblox and is co-founder-in-chief of, co-editor-in-chief of ACM's Games Research and Practice. Take it away.
Thank you. Hi, I'm Kenny.
And I'm Yogari.
And together we co-founded 3Finery to bring magical interactive experiences to life.
And we're excited today to show the first intermediate reality chat with MagiPeeps.
Yes, our MagiPeeps here are 3D printed, physically embodied conversational AI avatars that we connect and play with together over the network with chat and augmented reality.
And for that, let me introduce our friend here, Quinn.
Sure, and let's go. And keep an eye on the server telemetry screen showing all of the AI chat tokens being formed live into synchronized facial animations.
Hey there, you look interesting. Who are you?
I am Quinn, a mischievous and helpful MagiPeep here to bring a sprinkle of magic to your day. How can I assist you, my friend?
How did you come into being?
I've been around for ages, even before stories and books were written. The MagiPeeps have always been magical friends to people. We've just been a little hidden and overlooked lately, but we're back now, ready to spread joy and help in any way we can.
So Quinn looks and responds so realistically because instead of using regular AR rendered graphics with light estimation, we directly steer optical appearance with the deformations of the character's facial animations to pick up all the dynamic lighting right here on stage.
We're also painting the surroundings, so when Quinn chin's move or mouth opens, we feel the details so they match the background.
That's so cool. And not a little bit of thanks to Ken Perlin's Clay Vision demo 10 years ago.
So what about this pirate here?
Yeah, we scanned this Blackbeard sculpture to bring him to life too. Hey, what if we can transmit the same story to Quinn and Captain Blackbeard like a TV broadcast transmitted to see and hear on physical objects in your home?
That sounds like a great idea. Quinn, what Pirates TV news brief could you share?
Of course. Sharing is caring, as they say. What would you like to share? A secret, a laugh, a magical adventure? Just let me know, and we'll share it together.
Just let me know, and we'll share it together.
Oh, that's a little bit disconcerting, but super cool to share stories broadcasting live to toys anywhere. Wait a second, why don't we tell them to meet each other?
Like how Vince Cerf did 50 years ago with Eliza and Parry, but right here in front of us tangibly. Quinn, with the famous pirate Blackbeard here with you right now, what would you like to ask him?
Yes, that's me, Quinn with a 9. How can I assist you today, my friend?
What would you like to ask Blackbeard?
I'm sorry, but I'm not quite sure I understand your question. Could you please rephrase it for me?
Fearsome pirate. Me and me crew be on a mission to protect the Earth. What can you do to lend a hand, me hearty?
Okay,
Ahoy, Blackbeard. It'd be an honor to meet a fearsome pirate like yourself. As a MAGP, I'd be bound to protect the Earth too. We can join forces and spread the word of sustainable living, reduce waste, and take care of our oceans. Together, we'll be an unstoppable crew for a greener world.
He will reply.
What's Ahoy, matey Quinn. 'Tis a pleasure to meet a fellow Earth protector. Join forces we shall, spreading the word of sustainability far and wide. Together, we'll sail the seas, reduce waste, and keep our oceans pristine. Onward we go, a greener world awaits.
So awesome. Of course, it's easy to get carried away with text-driven continuation responses that might seem like real intelligence. But perhaps we can have a question from the audience in this multi-way AI-human conversation.
Anyone wants to ask a question to Quinn or the pirates?
Hey, Blackbeard, where do you sail?
Ahoy there, as a pirate, me wares be not for sale, but me heart is, and I be sailing the highs, seeking adventure and protecting the Earth. We be spreading the message of sustainability and lending a hand wherever we can. Wherever ye be, we be there in spirit, ready to lend a hand.
Thanks, Quinn, Blackbird, and everyone, and we look forward to releasing. Thank you. We look forward to releasing our MagiPeep chat and play platform very soon on the App Store for everyone to join in the fun.
Yeah, and thanks finally to our funding support from Edinburgh Napier University, Innovate UK, and the European Commission. See you soon.
Thank you.
Well, AI has gone rogue already. That was great. All right, next up, we have sonification of a juggling performance using spatial audio. And the presenter is going to be here, Wojtek Leichner. Wojtek is interested in human-computer interaction. His specialty is behavior simulation, multi-agent systems, computer vision, VR, new media, and spatial audio. He develops both hardware and software, and Wojtek is pursuing a PhD at Czech Technical University in Prague. Wojtek?
Hi, thanks. So I'm Wojtek Leichter, and today I'm presenting dejuggling, sonification of expressive movement performance. So what we have done, we have basically developed a wireless sensor that's small enough to be put inside a ball. And you can hear that as I throw the ball and as I catch the ball, we are sending node on and node off events over Open Sound Control Protocol. And you can also notice as I throw the ball higher, the pitch is higher, and if I throw the ball low, you can hear more bass for sure. So let me move to the stage there. And let's see what happens like if we use more of these balls. Just quick check there. Just like, yep, let's hit this play button. Okay. Perfect. So if we have more balls, like what we can do is assign each ball different instrument. And immediately you can hear that we can use an inherent rhythm in juggling patterns to produce like musical compositions. And also you can notice it's pretty hard to talk and juggle at the same time. And you're probably all wondering, okay, so what will happen when I drop the ball? So let me assure you, this will And that's about it. Like it's a real demo, so who knows what happens. But we also wanted to do something different. So you can not only map a parameter of one ball to directly one synthesizer, you can also map it to different synthesizer or for a different musical instruments for that matter. Okay, it's a bit show-off, I know. But the important thing is, like, you can use the stack to not only for juggling, you can use it as a VR controller. We are streaming basically the rotation 360 data to the computer, and it's received in a DAV Ableton, or it can be Logic Cubase, whatever you like. So that's that. But we have also developed a standalone application in processing Java that can also produce sound. Okay, I will try to step it up a notch. And now you can hear an arpeggio. An arpeggio is a series of notes that is produced while one ball is in the air instead of just a single note. Woo. Okay, now probably the fall will come. Oh yeah, it's here. Woo, yeah. Come on. I always like when it's falling, that's a good sign. I don't care. I have 3 more, you know. Also, I want to say hi to Pavel Husa, who cannot be here today with me. So maybe one takeaway, don't go on vacation to Iran before you want to go to USA. Just a side note here. Okay. And we also presented this here at SIGGRAPH as a short art paper, so you can find more information there. And we also have a website, triggerear.com, so you can learn more about us there as well. So thank you very much. It was a pleasure here.
Oh, that was truly impressive and nerve-wracking a little bit. And you know, juggling performance is impressive, yes, but he's also juggling the computer back there and the 2 stages. So that was great. All right, next up, we have interactive AI material generation and editing in NVIDIA Omniverse. And 3 people will be on stage with me here today. Well, we'll find out. Hassan Abu Haya is a research engineer at NVIDIA Toronto AI Lab with a PhD from Heidelberg University. His research intersects machine learning and graphics, focusing on ML tools to streamline 3D creation and rendering. We also have Alex Zook. Zook is a research scientist at NVIDIA with a PhD from Georgia Tech in 2016. He researches the application of AI and machine learning to augment simulation and game design and development practices. Masha Shugrina is a senior research scientist at NVIDIA Toronto AI Lab, where she manages a group focused on creative applications of AI and with efforts to accelerate research. Masha earned her PhD at the University of Toronto and has previously spent many years as a software engineer before coming to research. Yeah.
So first up, I'd like to introduce Hassan, our project lead, who will be joining us from Germany to introduce the technology, while Masha and I will be demonstrating it on stage.
Hello, SIGGRAPH. So today we're going to demo a prototype that can generate PBR materials in near real time. It shows how generative AI can help artists expedite tasks and iterate quickly through ideas. This performance is a game changer for integrating AI into artist workflows. I see that Masha has already started working on our 3D scene directly in NVIDIA Omniverse Composer. So I turn it over to you now, Masha.
Hi, everyone. I'm thinking of using an exposed brick texture for this wall.
Whoa, those bricks are huge.
These textures are seamless, so we can tile them as much as we want.
All right, but you can find simple brick materials in any materials library. How about let's mix it up a bit and paint some of those bricks blue?
Sure, let's try. With some bricks painted blue. Generation is accelerated by tensor cores in NVIDIA GPUs and is very fast, so we can try a few. And by the way, we're not just generating the RGB texture, but also normal, roughness, and ambient occlusion maps, all seamlessly tiling.
So that looks fine from here, but can you zoom in a little bit? Yeah, that's kind of low resolution. Can we increase the resolution?
Let's upscale this texture in the background while we explore other things. We will come back to it later. So how about moving on to this pillow here? Did you have some ideas for that?
Yeah, can you pull up the photo I sent you earlier? I know it's not perfect. I didn't exactly lay it flat, but can we work with that?
Sure. Let's first edit this image to make it tileable like all our materials. After the AI inpainted the boundary, all the generated maps are seamlessly tiling on the edges. And we have normals and other channels, not just the RGB. Is this what you had in mind?
Yeah, that's looking pretty good, but I wanted to explore a different style with this as an inspiration. Can you make it look more cross-stitched?
Rather than creating a new material from scratch, let's refine what we already have with an additional style prompt. The strength parameter allows us to specify how much modification the AI model can perform. So let's give it a try. Maybe something like this? What do you think?
Yeah, I like that. But before I forget, what happened with the wall material? How's the upscaling coming along?
The results should have come in by now. So let me go ahead and assign the upscale material to the wall.
Can you maybe change the lighting a little bit? I'd really like to better see how it interacts with the 3D material.
Let me tone down the overall lighting so we can really see how the generated normals react to the light.
Oh, wow. That really does make the 3D pop. That's great.
So I'm noticing that we still have this centerpiece here that's completely blank. Did you have some ideas for that?
Yeah, so for consistency, I wanted to start from the same inspiration images before, but this time I wanted to explore a look that would better complement the exposed brick wall.
Sure, we can create all sorts of materials from the same pattern. So how about we try something like a Roman mosaic?
Oh yeah, the tiling in a Roman mosaic would go nicely with the exposed bricks.
Let's see what we get. How about something like this?
That's pretty good, but it kind of lacks a focal point for a centerpiece. Can we do something about that?
We can do that. We can ask AI to modify a section of the image given an additional prompt. So how about adding some macaw parrots right here?
Those are pretty good parrots. They really do bring the whole room together now and give it a complete look. So, as you can see, using AI has been a lot of fun to explore different styles for the room and try out our different ideas. AI has really, worked quite naturally in our workflow.
We just saw how empowering AI can be when we can iterate with it in real time, because creativity is about exploration, but also iteration and control. To learn more about our technologies in generative AI for 3D workflows, check out NVIDIA Picasso. Thank you.
Wow, this is really amazing. I don't want to use anything else for materials anymore. This is it. That was great. All right, next up, we have super fast strand-based hair rendering with hair meshes. And I have to say, I'm very proud to announce 3 of my students upstage here, and they're going to be presenting our work together. Gaurav Bokhari just completed his master's in computing and starting his PhD at the University of Utah, and will continue to work on real-time and offline rendering techniques. We also have Aysen Moltavo. Aysen is a principal computer engineer at Raytheon Technologies in Tucson, Arizona. He recently completed his MS in computing at the University of Utah. And also we have Eli Diaz. Eli Diaz is a PhD student at the University of Utah working on physics-based animation and simulation techniques.
For sure.
Take it away.
Thank you, Jem. Hair is a crucial visual component of virtual characters. Still, a strand-based hair model is one of the most expensive things to render because of its extreme geometric complexity. A full-resolution hair model, like this one, made by artist Lee Perry Smith, contains on the order of 100,000 hair strands and requires many millions of triangles to render. A model like this would take hundreds of gigabytes to store, but not this one, because it doesn't actually exist. It's generated on the fly during rendering from a hair mesh. A hair mesh is a volumetric structure that was introduced for modeling hair by Professor Yüksel and included in his hair farm software. We are using it for super fast hair rendering on the GPU. 100,000 hair strands are generated during rendering from this hair mesh using mesh shaders. Turns out, this is so much faster than the traditional way, which is pre-computing the strand-based hair model and then rendering it. In our case, the hair strands are never stored. We generate them, render them, and then throw them away. The entire hair groom is defined by the hair mesh and a bunch of procedural styling parameters. This also makes it super cheap to switch between different hairstyles or tweak the hairstyles on the fly. Aysen, can you tell us how we can style the hair strands? Yes, I can.
What you see on the screen is something very similar to a traditional, very simple hair groom coming from a DCC tool like Maya or Blender. If you want to change the style, you need to go back to your tool, restyle, re-export, re-import into your game engine. But what if we can do this directly in our game engines? This is exactly what we built. As you can see on the UI here, we implemented a very few common operations for styling. We have clump, curl, frizz, kink, and fuzz. Of course, we haven't implemented all the available hairstyling functions, but if you want to add your custom one, it is very easy and straightforward to do so. Graph, let's make this a little bit more interesting by adding kink.
Let's do it.
So you can see we can play with the strength parameter to add more kink to the hair. Also, if we want to, we can isolate the style to be just closer to the tips. God, I wish I had hair to style it like this. A typical hair groom is hundreds of megabytes in size. Our system only needs kilobytes to define one hair mesh. This means that between the memory of a single typical contemporary hair groom, we can store 100,000 unique hair models. We just need to store the hair mesh and these few parameters. These are some quick styles we created with this tool. With this technology, it is easier than ever to experiment and isolate and play with hairstyling. I can't wait to see what the creative community can do with this. But not only artists, just imagine the possibilities that a few simple controls in your games can open for gamers and the creative and custom hairstyles they can do for their in-game characters. Ellie, now that we have hairstyling, how can we make it come alive?
Come alive with hair meshes, that's not just easy, but super fast. Hair meshes allow us to animate the strands and move them around. Watch how our model is moving with our mouse and the hair is responding accordingly. But these animations are handled by animating the hair mesh alone. Our hair mesh is actually simulated using a precision-based dynamic simulation that maintains the shape and form of the original hair mesh, even recovering the shape after intense simulation. Since our strands are generated on the fly, they just follow the shape of the hair mesh. But can we do more? Here, we have a Utah teapot model. Let's put some hair on it. Watch how it moves around our empty world. I think it looks a little lonely. Can we add some friends? Maybe a couple more? How about a dozen? How about a couple more dozen? Gaurav, how many teapots can we possibly have?
A lot more. With our system, we can render hundreds of teapots.
Oh my gosh, the teapots just keep falling. The teapots don't have full resolution hair meshes, right? They have to be instantiated.
Absolutely not. What you're seeing here, let me prove that these are actually full resolution strand models. Let's take a closer look. As you can observe, each teapot here has 20,000 hair strands. And overall, total, you can see 4 million strands rendered currently in front of you.
But that means 250 million triangles. We can't possibly do that, right?
Absolutely not. What you're seeing here is just a fraction of the amount. As we're doing strand-level rendering, we can actually deploy clever LOD techniques to not only change the curve details, but the strand counts based on the camera distance.
But what about shadows and hair color?
Shadows are super fast. Even for a large scene, since we're doing strand-based rendering, we can approximate opacities of each hair's fragment and render volumetric shadows. And for hair color, we can actually simulate light multiple scattering using state-of-the-art techniques like dual scattering approximation.
Wow, we've seen beautiful hair models from this stage before, and now, for the first time, we can show you hundreds of them in the same scene. With our super fast hair rendering system, there's no excuse for not having more full-resolution, dynamic, customizable hairstyles for every game character, no matter how large your scenes are. Thank you.
That was a lot of hair and a lot of teapots. So somebody asked me, why put hair on a teapot? Why not? Okay, next up, we have Napkinmatic App Mode 3D Mesh and Texture Designer. And our presenter is going to be Yosun Chang. Yosun Chang is a mad scientist, artist, hacker, entrepreneur, or AI industry veteran and visionary who has a knack for assimilating emerging technologies into novel software that win awards under deadlines such as hackathons. So, Yosun?
Hi. Napkinmatic 3D can turn your napkin sketch into a texture 3D model. And to let you know that we indeed have a live demo here, we're going to show you that we have a live, well, let's do that a little after this, a live sketch that's happening here. We have recruited an artist who is live sketching, and here we go. Anyways, so Utam Grandi has done illustrations for economists Andrew Kaplan, screenwriter Keith Bearden, and Lillian Squirts, and now our live demo. So, many millennia ago, our ancestors first left drawings on cave walls with their bare hands. Sorry. And a number of pioneers of CG history, they've happened since then. Ada Lovelace and a ton of these other people. So since then, we have made many advances in 3D graphics. But we have gone so far away from the natural creation interface that was once universally understood by everyone. And today, we are literally going back to the drawing board to actually create 3D modeling stuff from simply drawing on paper so that you can spend more of your time focused on your ideas. Since this is a live demo, I'm actually, for good luck, going to restart this. It's actually been running here for the last 2 hours. And Newsway is my first name backwards, and AI Magical is my new company. All right, so this is our live sketch drawn by our live trance reality artist. And so step one, how to use this Napkin Math 3D app. We take a picture of our sketch and top down, and then we crop it. And now we use our light scalpel tool to create napkin space objects. We're going to do a really quick test here to turn the sketch in using just a couple apps from AI for 3D App Store. Avatar SDK's sort of bust app, and then let's have this convert, hopefully in seconds, to just a quick check. Here we go. So turn that particular drawing into a 3D model on our iPad in seconds. And now we're going to start doing something more interesting. We're going to actually use AI texturing to give this life. So we're using light scalpel again to create an object here. And we're going to use the OCR to actually create the button. And George Lucas, and also Rembrandt. And then we're going to use the light scalpel to connect things. And so ControlNet Scribble is now starting. And so now it's working. And uh-oh. Oh, this is actually a bad one. Let's try it again. Every once in a while, just so you know, it's live demo, this kind of generates things that are a little bit too abstract for recognition as a face. So we're hopefully going to get lucky, and this one will be more recognizable as a face. If not, I think Rembrandt is usually more realistic and stuff. Here we go. So if you're wondering, this is the original sketch. This is what ControlNet has turned it into. So you can see that it's very true to the outline of the sketch. And so you have your expressive freedom. And then that, I guess because there's a couple of sort of odd lighting issues with the hair, it got turned into this particular 3D model. Okay, so let's do a few others. Actually, okay, let's just jump straight into interactivity mode, actually. So we actually have interactive app mode where we have a few apps here. One of them is a chatbot. And this chatbot actually lets you say stuff. For example, let's have our sort of George Lucas guy say what you've always wanted him to say, which is, I am your father.
I am your father.
Sorry, let's make him
I am your father.
You can also change his voice.
I am your father.
So yeah, this is actually fully rigged model. So we'll just generate another one for hopefully we'll get a better random seed for a nicer looking ControlNet texture of this. And great. Wow. Yeah, this is definitely a live demo, and sometimes you don't get the most aesthetically, but everything is actually true to the original outline here. So maybe this Da Vinci one will start to look good. Okay. Anyways, we hope that this has inspired you to rethink the whole concept of what 3D modeling can be like in the age of generative AI. We believe that software created to help maximize human potential is, the future, and this will allow us to freely and effortlessly express our creative vision. So we invite you to continue to envision UI so intuitive that it becomes transparent computing, enabling us to create at the speed of thought. And Napkin Math is coming soon to the App Store, and you can check us out at Appy Hour, and also SIGGRAPH Corgi. You can find me by finding the Corgi, actually. And yeah, come check out the demo, or download it on the App Store and stuff. Right? Cool. Thanks.
Wow, thank you. This was... Now you've seen the sketch-based interface has gone wrong, right? So it's like with AI, everything can go rogue anytime. That was great. All right, next up, we have Metaphysics Live real-time hyper-real face swap. And on stage, will be demonstrating for us is going to be Henrik Dahlberg. Henrik is a machine learning engineer at Metaphysics. Specializing in computer graphics and machine learning for film production and live entertainment, Henrik has led the pipeline integration and participated in the research and development of various tools and systems for productions such as Star Wars, The Rise of Skywalker, Alba Voyage, and Disney's Aladdin. So, Henrik?
Hi, everyone. My name's Henrik. I'm really happy to be here today at SIGGRAPH Real-Time Live, demonstrating the groundbreaking work we are developing at Metaphysic. Metaphysic is the industry leader in developing AI technologies and machine learning research to create photorealistic content at large scale. Recently named Time 100 Most Influential Companies for 2023, we are focused on the ethical development of AI to support the genius of human performance. Today, we are excited to demo our real-time photorealistic face swap technology that we are actively deploying on film sets and music concerts. So our Chief Innovation Officer, Joe Plate, sadly couldn't be here today, so unfortunately, you're stuck with me to take you through the presentation. However, let's see if we can get Joe up here with me on the podium anyway with some AI magic. So David Singh, our Metaphysic Live operator for the day, is now going to demonstrate our real-time toolkit that will swap my face to Joe's. So what you're seeing now is my face swapped to Joe's seamlessly using our real-time AI toolkit. And our generative pipeline runs in the following steps. We ingest any input feed via SDI. We run face detection and identification. And we run our face swapper and our real-time compositor, and then stream the swapped result out to SDI or HDMI again. Our face detection and identification has been trained specifically to detect my face, and it places landmark on my face, which we use to drive the face swapping. The face swap module, which is at the core of our technology, is a neural network that has learned to encode the characteristics of the input face, process the encoding, and then decode it out to the target face, exchanging the former for the latter in real time. And now here you can see the raw output of our face swap before it has been blended with the rest of the camera feed. The network performing the swap has been reduced in resolution here to cater for real-time performance, and it's been optimized to be general and capable of handling any input face as a driver. And it's flexible to variations in lighting and other conditions. And if necessary, we have a pipeline that can ingest new views and novel input feed data to fine-tune the model's output here. And lastly, our real-time compositing module is seamlessly integrating the input signal with the swapped face. And here we use a superpixel-based color transfer algorithm to match the skin and lighting conditions between the source and target identities. So this real-time tool is our OpenCL variant of our more comprehensive offline toolkit that we actively use for high-quality visual effects production in Hollywood. On professional film sets, we're using our software to achieve final quality film frames and with full consent and approval from all parties involved. As you can see, the tool runs in full real-time frame rates and can be used for actors to preview their own performances live during film shoots. And it can also be used for live music productions or theater productions. Yeah, we can also swap several faces at once. So David, would you please join me at the podium? And now, yeah, we will swap David's face here to our female colleague Sarah's face. So there we go. If you can. Very pretty. And yeah, so I hope that you've all enjoyed the demonstration here today. And yeah, found it insightful for what the future of entertainment is. So to close off, Metaphysic remains committed to supporting all types of artists and industry participants. who've spent years cultivating their crafts. We're committed to providing efficient and innovative solutions that integrate the use of AI, while also addressing the very important issues of consent, compensation, and copyright. We have a small team from Metaphysic with us here today, so do stop by and talk to us if you have any questions. Thank you for listening.
Oh, that was really impressive. I was told that Yo would not be able to join us, but I saw him on stage. He was right there. That was amazing. All right, next up, we have real-time stage modeling and visual effects for live performances. Our presenters are going to be Taeyeon Ri. Professor Taeyeon James Ri is the director of the Computational Media Information Center and the co-founder of computer graphics degrees at Victoria University in Wellington. Also, Andrew Chalmers. Andrew Chalmers is a research fellow at the Computational Media Innovation Center. And Faisal Zaman is a PhD student, and Vic Roberts is an honors student at the Computational Media Innovation Center. Take it away.
Hi, everyone. My name is Andrew. Today, I've got a live streaming camera with me on stage. So that's you right now, live streaming. Hello, everyone. And if we go from our second camera angle, so that's live streaming from the other angle there. So if you wave, you might see yourself waving. So there you are. Hello. And on stage, oh, that person's in the way. We have Faisal. Can you sit to the side? Thank you. We have Faisal. Hello, Faisal. So this is an avatar that we've blended it into the environment, controlled by Vic. So Vic is able to navigate the real-world environment. Notice that there's mutual occlusion, that she's able to go around real objects. We're also able to provide Faisal the ability to push virtual content with natural hand gestures. So we'll give him a chance here. All right, yeah, good job, Faisal. All right, so how do we do this? So we've got those two live streaming 360 cameras, and we've mounted them with two LiDAR sensors. Those LiDAR sensors provide a 3D point cloud of the auditorium in real time. This is live streamed over the network and into a game engine. I'll switch over to my scene view to show that. Cool, so this is the point cloud projected onto a 2D plane. You might be able to spot Faisal waving his arms there, and the crowd, that's you, hello. But we can't use this depth map directly. There's plenty of holes throughout it, so we have to densify it. So we fill in the holes. It's a bit noisy, so we denoise it, clean it up a bit, and now this is ready for 3D composition. For the collision detection, we have to have a 3D representation of the world. So let me just switch the view here. So this is the auditorium right now. This is our collider mesh that we update based on that depth map. And this is updated in real time to allow you to interact with virtual content. So you, as the audience, are actually participating in our live demonstration today and will be able to interact with the virtual content. Let's switch back to our game view, and we'll show an example of a live performance scenario enhanced with visual effects. So one sec. We'll switch to the hierarchy. Cool. All right, so we can see Vic controlling the avatar now. They're able to move through the auditorium. There's a sense of depth. They're augmented within the environment. It feels like they're kind of there with us, if they're able to, with the mutual occlusion. Since we have the large-scale capturing, they're able to navigate large-scale environments. Oh. All right, we'll bring it back to the first area. Okay, looks like she's singing among you now. Okay, not sure how that will turn up. Okay, so we'll move over. We can also, I noticed that the stream is frozen. Let me just refresh the stream real quick. It's just refreshing, give it a moment. I do want you guys interacting. All right, can you give it a quick wave just to make sure it's running? I can see you guys, yes, good. All right, so you saw Faisal interacting earlier. Let's shoot out some balls. So I can see you guys at the back there really wanted to interact, so shoot a few at the back there. We can enhance this experience using visual effects as well. So let's add a bit of rain. Well, I'm glad you brought your umbrella, Vic. And, oh, looks like Faisal's brought his too. Well, sorry for the rest of you. We didn't warn you about the rain. Looks like the auditorium is starting to fill up with water now. Oh. This is our avatar in the water. Or I guess you could say our avatar, the way of water, except it didn't take over a decade to make. It's done in real time. Uh-oh, what's that? It sounds like a kraken. Be careful. Maybe you could wave your hands around, I don't know. Maybe I can help out. I'll try to shoot spells at it. It doesn't seem to be helping. Maybe if you can give a round of applause to summon something. Oh, yep, a magic flying orca. All right, it seems like it's protecting us from that kraken, so it's probably safe now. I think this is a reason to celebrate. We can also support live kind of musical acts as well. So this is a K-pop artist named The Hitchhiker. They're a K-pop musician, so this is them. And notice that they're very reflective. They're actually reflecting the real-world environment using image-based lighting in real time, updated. And there's another reason to celebrate. It's a special year this year. Let's do a little reveal. Yeah, happy 50th anniversary, ACM SIGGRAPH. And to celebrate, take one of these, our Stanford Bunny. All right, that concludes our demo. This is an early research prototype trying to solve a challenging problem to enhance large-scale performances. We are open for collaboration. Keep an eye out for our Televerse platform for more information. Thank you so much.
Well, you've been a part of the show, right? Wasn't that amazing? That was great. All right, next up, we will have your votes. Now that you've seen all of the 13 demos, let's decide which one wins the awards, right? Now, the jury is selecting the Best in Show award right now as we speak, and I need you to vote for the Audience Choice Award, right? I'll give you not 2 minutes or so to put your votes in. It's not that hard. You just need to go to this link, follow the link, or maybe scan the QR code if you haven't already. Or you can just type tinyurl.com/SIGGRAPH23RTL, and then just vote, whichever one you pick. It's fine. And in the meantime, there are some people I would like to acknowledge. Hi. Okay, so this is our real-time live committee. I really have to thank these people, Gracie and Andrew. They were helping me with figuring out what happened in the past and how can we do things. They answered so many questions. Emily is going to lead this show next year, and she was every bit of a part of it this year too. So thank you so much. You guys have been amazing. I also have to acknowledge the real-time live jury. The jury was absolutely amazing. So they have reviewed all of the submissions to our RTL program, and they've not just reviewed them, but they've also given them very clear feedback. There was long discussions on all of the submissions, and everyone got some feedback. And even the final pieces here that you see got feedback about how they could make their presentations even better. And in the end, we had this amazing show, and we're really, that's their doing. So I would really like to thank the jury. As you can see, folks in the jury have all sorts of various different types of expertise, and that is important to have a healthy jury for real-time live, because you've seen the types of demos we have here today, right? They're covering a large span of things in the context of real-time graphics. And jury also followed, I would say, a very, very strict conflict of interest process. And that was great. I think that was a good example for the Supreme Court, maybe. Okay, moving on. Now, I would also like to thank the real-time live team. Putting on this show is no small effort, and I'm just coming up here and talking about stuff. The real stuff is happening behind the scenes, and I have to say, Deanna, thank you so much. You've been super patient with all sorts of random requests and questions about all sorts of things for a very, very long time. And Brian, you are my hero. You're absolutely my. And Brian, Jeff, and Elena, and everyone else in Freeman AV team here, that an army of people here and in the backstage, they are the ones really driving this show. Thank you so much. There's no way to put this show together without you. You guys are amazing. And also, Carlos and Joe, this is how they're making sure that we are properly connected to the rest of the world. Like all our network connections and everything. I'm making sure that all these wireless devices you see up on stage still work with your thousands of cell phones in your pockets. Thank you so much. You guys are amazing. And of course, I would also like to thank NVIDIA. NVIDIA has been our sponsor. I would like to thank them for their generous contributions to SIGGRAPH and to the real-time live program specifically. Thank you. All right, has it been a few minutes? You guys pretty much done? You've decided on your votes? Because we're going to shut it down any second now. Okay, we're shutting it down. We're done. This is real-time live. All the votes are in. So while the team is tallying up the votes, I have an important announcement. The important announcement is going to be about the panels. Real-time Live is a show here. Things go really fast here, right? You guys did not really get a chance to ask any questions to anyone, to talk to people. Now, we're going to facilitate that tomorrow. Tomorrow morning at 9 a.m. Tomorrow morning at 9 a.m. in room 403AB, we're going to have the real-time live panel. Now, this year's real-time live panel is going to be a little bit of an experiment. We'll see how that will go. Instead of selecting just a few presentations, we're actually invited all of the real-time live presenters to the panel. So there's going to be quite a few people on that stage. And it's mostly going to be driven by your questions, and maybe a few presentations maybe, but this is mostly going to be like a Q&A session, just to give you guys some chance to interact with everyone. I'm going to be there too, don't worry about it. So please do not miss tomorrow's real-time live panel. It's going to be an interesting experiment, and how that will go will depend on your participation. So I'm hoping that you guys will be there. So I'm hoping that we are ready for the Audience Choice Award. Now, I have no idea. There's nothing in front of me that highlights anything. So you guys will learn who won the Audience Choice Award exactly at the same time as I will. Are we ready to go? Okay, the winner of the Audience Choice Award is real-time stage modeling and visual effects for live performances. Come up on stage, guys, please. Come on, we have an award for you. That was a fantastic presentation and really great work. Thank you so much. Very, very well deserved. All right, we have one more award to give. Just one more, and that's it. All right, the Best in Show Award. And jury had a few extra seconds to decide. I hope they did, and I hope the results are in. Are we ready to go? If we are, let's find out. The Best in Show for Real-Time Live in 2023 is a great suspense. I can't give you any hints, guys. Oh, there it is. interactive AI material generation and editing in NVIDIA Omniverse. Come on up here. A really fantastic presentation and really, really great work. You can bring us on. Oh no, we lost Hassan. Oh, he's there. All right. Oh. Congratulations.
Thank you.
That was wonderful. Well, and this concludes Real Time Live for this year. Thank you all for coming, and for Twitch, thank you all for watching till the end. I hope you did. And please come back next year and continue enjoying SIGGRAPH. Yeah.